Hello, welcome back to Cracking the Cryptic. The voice seems to be holding up, thank goodness, so maybe I'm not coming down with the normal winter flu at the moment, or maybe I am, but slowly. Anyway, we have a puzzle today by Scott Williams. Scott has featured on the channel a couple of times before, and Scott is especially memorable to me because his mother Emily helps out a lot with the channel and leaves a lot of positive comments and is a great person all round for us. So I'm not saying Scott isn't, I'm just saying I have less dialogue with Scott than with Emily, but Scott sends us puzzles sometimes, and I think he saves up till they're really quite good. So we've got a lot of confidence going into it that this is going to be fun, and we will have a look at it in a moment. Don't forget that on Patreon you've got Blobs's rather brilliant The Hobbit Sudoku Hunt, where you have to solve Sudokus, contribute a couple of digits from each puzzle to the next puzzle and solve again, and you get to keep going on a marathon quest, just like The Hobbit himself. And when you emerge at the end, you send us the solution, and you may be in with a chance of a prize. Now, that is on Patreon, along with lots of other content, including crosswords and long Sudoku solves and extra puzzles. So do check it out, connections videos too. Also, of course, there's all of our apps which feature Arrow Sudoku, and our latest Fog of War Sudoku, which is available and is proving very popular. Do treat yourself to that. It's fantastic. You can also find on the links under the video SVEN'S Sudoku Pad and our merchandise, and the link to this puzzle. The puzzle is called 35. I don't think I know why. It's by Scott Williams, and I'm going to go through the rules now. So, normal Sudoku rules apply. 1 to 9 goes in every row, every column, and every 3x3 box. A clue outside the grid gives the sum of the digits along the indicated diagonal. So those 3 add up to 10. I can tell you they won't contain repeats because they're all in the same box. Those 9 digits add up to 41. I can tell you there will be at least one repeat amongst those, because if there wasn't, they would be the digits from 1 to 9, and I know what they add up to, and it's not 41. Now, the middle 3x3 box is a magic square. That's why it's in the cage. Each row, column, and 3-cell diagonal of this box must all have the same sum. So that will add to that, will add to that, etc. Digits along an arrow, sum to the digit in the arrow's bulb, and that's it. That's what we get. These outside the grid clues are known as little killer clues, so if I refer to them in that form, that's why. It's a kind of very old name when they were one of the very few variants of Sudoku. And we were doing these puzzles back then, at least in championships and stuff like that, so that's why I know that. Anyway, we are doing this puzzle today, one of 2 we do every day on the channel, normally released at 8:30 and 11 p.m. UK time, and you can set your clocks by it when I don't make a mistake on the release time. Now, let's have a look at this one, and let's restart the clock. Let's get cracking. Okay, so I say this as though I'm going to dive straight in. I don't know where to dive straight in on this puzzle. Yes, I do. The magic square in the middle. Let's colour it yellow. Right. I will tell you a couple of interesting theory bits about the magic square. The central cell is in 4 different sums of 15, and there is only one digit. You could go through them and work it out, but there is only one digit that has 4 different pairs that it can pair up with, that it can join up with to make a sum of 15, and that is 5, which goes in the center. Now, the other thing to think about is how many combinations 1 can go in. And if 1 went in the corner, it would have to be in 3 combinations, but 1 can only be in 2 combinations. They are 1, 7, 8. No, they're not. We're adding up to 15, aren't we? They are 1, 5, 9 and 1, 6, 8. And that means 1 can't go in a corner cell, so it must go in one of these cells, along with 9 opposite it. And then you can work out that every row, column, and 3x3 and 3-cell diagonal in this box needs either 3 odd digits in it or 2 evens and 1 odd. and we've still got 3 and 7 to place. So if you were to put them in corners, the whole thing would fail somewhere. So they go in these cells adjacent to the 5 as well. And then the corners are the even digits, 2, 4, 6 and 8. And I mean, you could just start by writing those in, because magic squares always have this form. And hopefully something we do in the puzzle will then start to narrow these things down. But it hasn't really done a lot for me at the moment. There's not a lot to go on in this puzzle. It's not a fog of war puzzle, but it is nonetheless pointing some interesting things out. Let me just enable the pen tool and draw in the 10 diagonals, because there are 4 of them and they're very symmetrical. I'm just going to draw those to your attention. And there are 4 ways to make up a 3-cell 10 diagonal like that. 1, 2, 7, 1, 3, 6, 1, 4, 5, and 2, 3, 5. It would be very amusing if that was one of each. Okay, I reckon, I don't know, I'm going to get rid of the yellow colouring. We're just going to remember that's a magic square for now. And that's because I want to do some other colouring. So I'm going to colour all these cells and do some maths and see if it helps. I mean, I was about to say I reckon this is it, because I can't see anything else that we can start with. But what I'm going to do is compare the total of these 3 diagonals, which you'll notice the cells I've highlighted there are the 30 diagonal, I don't know why I'm trying to do this, the 40 diagonal and the 42 diagonal. And I'm going to add them all up together. And those add up to, so the purple cells total, it's quite easy with the zeros for once, 112. Now, yeah, and that is an interesting comparison. It's an interesting comparison with boxes 3, 5, and 7, I think, which add up to 135. Now, how do I know that? I know that because of the secret, which I'm about to share with you, and nearly did earlier. The sum of every row, column, and box is always the same, and that sum is always 45, because that is the sum of the digits 1 to 9. Now, boxes 3, 5, and 7 will each contain a set of the digits 1 to 9. That's part of the rules. So they will add up to 45 times 3, which, as you know, is 135. Now, I am comparing that with the 112 that I got from the purple cells. And the result of doing that in my head is that there is a 23 difference, and green outweighs purple by 23. Now, what I'm next going to do is delete the overlapping cells that are in both colours once each. And what must still be true, because I've taken exactly the same numbers out of one set as out of the other, what must still be true is that green outweighs purple by 23. And yes, look, these are on the 10 diagonals. And in fact, this is a 15 diagonal. Right, we know that those two add up to 10, because whatever, this diagonal has to add up to 15. I don't know if I mentioned this when I was doing the magic square theory, but because the box adds up to 45, I didn't mention it because I didn't do the secret. Because the box adds up to 45, you can divide it into 3 rows and they all add up to 15. So that's the sum of every row, column, and diagonal. Now, if that diagonal adds up to 15, those 2 green cells, you subtract the 5, they add up to 10. I'm going to remove them from the calculation. Now, green outweighs purple by 13. Now, ordinarily, comparing 4 cells against 4 cells, that wouldn't really be that exciting. But I think it is. I think it is, because of these 10 diagonals. So let's make purple the absolute minimum they could be. And they could all be 1s, except I've just seen they couldn't. But let's imagine they could all be 1s. I'm just going to write those in as though they were, so you can see the maths here. If they were all 1s, then the green cells would have to add up to 4, which is the total of those purples, plus 13, and that is 17. But these 2 diagonals only add up to 20. So these 2 cells are now, the other cells on the diagonal are now at maximum a total of 3. And this is an orders of magnitude problem. I think it's a degrees of freedom problem. but I've seen something else with the purple cells. Anyway, I think this is a degrees of freedom. We've worked out that if these purples were only one each, these two cells in yellow would be maximum 3. Actually, they would actually very specifically add up to 3 because there is no wiggle room on green versus purple. We know that that adds up to a difference of 13. However, the important thing is that first of all, these purples, we don't know that they're 1, but they only have 1 degree of freedom anywhere to increase. And if they have a 2 amongst them, the yellows are both 1s. That degree of freedom is either going to exercise itself on the yellow cells or the purple cells. And it's going to do it by pushing one of those cells somewhere up to a 2. Remember, we're comparing greens against purples. And because we're subtracting greens from the 20 total, that's why these yellows and purples move the same way when the degree of freedom is exercised. Now, here's what I noticed about the purples, because actually I wrote 1 into all of them. Where would the 1 go in the central box if you wrote 1 into all the purples? There's the only place left is there. And that's the only place, well, that is one place we know 1 definitely doesn't go. So now we know the purples are not all 1s. One of them is a 2. And that means the 2 yellows are 1s, and we can write them in. And that is going to look at this this arrow. Those 3 cells can't contain a 1. Now they must be 2 plus 3 plus 4, the minimum they can be, and that is the maximum circle of 9 to make that sum work. This is now a 1. We found one of the purple ones. We still have 2 more to find, and a 2. Now, does this arrow work the same way? It doesn't. It could have a 1 on it, and that 1 could be there. And this would be a 2. Otherwise, it is again a 2, 3, 4 arrow, and that's a 9. I'm not sure how we resolve that, so I'm probably going to need to do some extra thinking now. Well, first of all, I can take 1 out of this cell by Sudoku, and therefore 9 out of this one by thinking about the magic square totals. And that doesn't get me very far. Now, I've used the total of the 30, 40 and 42 diagonals, but I have not used the individual ones. And that might be something I could do. I haven't used the 41 diagonal. I haven't used the 10 diagonals in boxes 1 and 9. I haven't really done a vast amount. I can write a 1 in one of those cells. That's just Sudoku. And very unhelpful. Oh no, hang on. This digit, this is interesting. This is not 1, 2, 3 or 4, but it's on this diagonal. That is 5, 6 or 7. And it goes with digits from 1, 2, 3, 4 to make up the 10 diagonal that it's sitting on. That one's not allowed to be a 1 by Sudoku. So this one can't be a 4 anymore, I reckon. I don't know. Is that enough to do anything quite there? Not really. I don't know. One of these other purples is... 2 of these other purples are going to be 1s, and I think whichever 2 it is going to leave the 1 in one of... Oh, look, we've got a 9 here looking at this. Right. So that can't be a 9-1 pair. That must be a 3-7 pair. That must be a 9-1 pair, and we do know the order, and now I know which purple cell doesn't have a 1 in it. It's that baby. And the others do, and purple and yellow have all done their jobs, and the colours can be removed now. Now, that 9 has to be surrounded by a 2-4 pair to make 15. That 1 has to be surrounded by a 6-8 pair. There are still 2 possible ways for this magic square to work out. I don't think we get the information yet on how to do that. So, sorry, what I'm trying to do is put a 1 in one of those cells, a 1 in one of those, either on the 10 diagonal or on the 41 diagonal, which I haven't really done any thinking about. Ah, one is now off this arrow, so that's another 2, 3, 4 arrow with a 9 in the circle. 9's in one of those two. Everything else in these two boxes is 5, 6, 7, 8. I'm prepared to pencil mark that now. Things are hotting up on these diagonals, actually. We've got a 9 on the 30 diagonal. Let's add that up and look at the minima. So 9, 10, 12, a 2, 3 pair there and a 2, 3 pair there would take us up to 22. And then we have a maximum of 8 in that cell. That's disappointing. Let's look at the other side, the 42 diagonal. Oh, the 42 diagonal has 3 1s on it. Those are, knowledge bomb, quite low digits. Right, yeah, let's draw a line through the 42 diagonal because I think it is interesting now. What are the biggest digits we could put at these two ends? Well, I suppose they could be 9, 8 pairs at both ends. That would add up to 34. 17 in one box, 17 in the other, 34, plus 1, plus 1, plus 1, 37. The absolute maximum so far. And then if this was a 3, we still wouldn't get to the total. So that is a 7. And that's going to finish off our magic square. We put in 3 there. Now the 7 has to be surrounded by not 8, because that would already add up to 15, but 6 and 2. And the 3 is surrounded by 4 and 8. And the magic square is complete in the center. Now I can take 6, 8 out of those cells and therefore 5, 7 out of those two. That's not, in fact I can place 2 in this box. I hadn't realized that was coming. Nine is up in one of these cells. Oh, I can take 6, 7 out of those two, and therefore they have to be in the other two in the box. That can't be a 2. Yeah, we're going along. We're going along. We haven't got there yet. And the trouble is, I used a 7. How many degrees of freedom did I have left? I have 2 degrees of freedom. If I use 9, 8, 1, 7, 1, 1, 9, 8, I'm up to 44. I can only lose 2 from that. So I could only come 2 down from a 9, 8 pair in one case. So 6 is the lowest digit that can be on this line. Obviously these cells can't have a 9 in because they're seeing 9s in the grid. Now, do I have to use that in concert with the full 9 cell diagonal somehow? If I'm using such big digits there, what have I already got on this? 15, obviously, in the central box. Plus 1 and 1 is 17. The other 4 cells add up to 23, definitely. But there's quite a lot of freedom. Okay, maybe I have to go back, I don't know, to the 30 diagonal. Where we've now got 15 in the middle cells. This digit can't be 1, 2, 3 or 4. That's at least a 5. And I'm only trying to get to 15 in these 4 cells. So the other 3 have a maximum sum of 10. That feels almost significant. I don't think it is quite useful. Now, the one diagonal I haven't looked at all, and we might as well, is the 41 diagonal, but, oh, poor effort. But I don't know. I don't think it's going to be very useful. We've got obviously 15 on it in the central box again. These two add up to 26 for 6 cells. That's That's not very helpful. It's not what I want. I'm missing something here. Sorry, I don't know quite what we're meant to be doing next. These are from 3, 4, 9 and include a 9. That seems very similar to those two. And it is. Ah, that has become a 1 at some point. So this isn't a 1. That's what we're meant to be doing next. This is the 1 in the box. Some bell started ringing in my ear. That's not my phone. Although the phone then makes a funny noise as well. Right. These don't include a 1, but they add up to 10. They are now 5, 3, 2. That's the only way you can get there without a 1. So that's a 5. Surrounded by a 2, 3 pair. That 5 rules 5 out of here. Now, this blue diagonal, I have to keep doing the maths because I can't remember the sums I've said. 15 away from 30. These other 4 cells add up to 15, and that one is at least 6. The maximum for the other 3 is 9, and they can't use 1s. So this could be a 2, 3 pair. The maximum for this cell is 4. If that was a 2, though, the maximum for these two is 7, not using a 1. They're selected from 2, 3, 4, 5. That one can't be 5. And look, I've got a 2, 3, 4 triple in the column. These are from 6, 7, 8. I am wondering about adding up this whole box, but that might be a step too far at the moment. Oh, and on this grey diagonal, I've now got 21. I've got 4 more cells that add up to 20, but that is a very average number. In fact, since 5 is the average Sudoku number, it doesn't get more average than that. Okay, up here, I don't know. I was trying to add those blue cells and the green cells. It doesn't make a lot of sense. In fact, there may not be much more I'm able to do in terms of using those long blue, red and yellow diagonals, because what I can populate on them is a function of what ends up in the green cells. Triples. Look, there's a 6, 7, 8 triple in the bottom row. So that can't be 7. That's a 5. This is interesting. There's a 6, 8 pair now in row 7. There are some interesting things going on. I just need to... Oh, look, there's a 4 in one of those 2 cells. So where does 4 go in box 9? It goes there. Now where does... That's a 2, 3 pair left in row 9. I've got 5 and 9 to put in those 2 cells. Sorry, this is row 7. I think I just called it row 9. But I've got 5 and 9 to put in those cells. 9 does not go on the 10 diagonal or it'll break it instantly. That 10 diagonal becomes 5, 1, 4. These don't have a 9 in. They are a 6, 7, 8 triple. That is 2 or 3 in the corner. There is a 9 in these 2 cells. And whatever that is from row 9 is going in them as well. It's nearly unwound, but it hasn't. I thought this would go a bit further. It's a very clever puzzle. Now, this diagonal, what's happened here? In fact, all the diagonals have improved slightly in terms of, not the blue, but red and yellow. Actually, maybe yellow is one. First of all, 15, 25. Those 3 add up to 16 now. How am I going to remember that? Is yellow a slightly 16-ish number to you? Yeah, I'm not sure I can use that. Let's try this yellow number though. So we've got 10 there. These 4 cells add up to 32, which is an average of 9, 7 each. And you can't put a 9 down here. That's it. These 2 are maxed at 7, 8. These 2 are 8, 9. And that gets us there. And that diagonal is basically complete. I've got a 7, 8 pair that make that a 6. I'll look at the blue diagonal in a moment. Let's just see if we can do some Sudoku. We can. 6, 7, 8, 6, 8, 7. Yellow is completely finished. This is now a 9-8 pair, and I know the order from the 9 in box 3. That sorts out 8-5. I still can't do the 6-7 pair or the 2-3-4 triple. I've got a 10 diagonal to deal with here, but I've got this red diagonal. Let's look at that. So 15 there, plus 9 and 1 is 25, plus 1 is 26. So the 3 remaining red cells add up to 14. That is a 2 or a 3. So these two add up to 12 or 11. And remember, I've still got 7, 6, and 5 to place in this box. Or, well, no, 5 could be there. So 7 and 6. Yeah, one of them goes on one of these diagonals, the green diagonal, and the other one goes on the red, surely. I'm not allowed for those to add up to 14. Let me just check my maths again. 15 and 10 is 25. Not quite, but it is true. 7 and 6, one of them goes on that diagonal, so it's either 7-2 or 6-3. One of them goes on this diagonal, but that's a little harder because these two red cells add up to 11 or 12. That can't be a 2 by Sudoku, so that can't be a 7. How are we meant to get this cracking along? I don't know. And I've got this 10 diagonal still to consider. If that has a 1 on it, it's there, and those two add to 9. Can it be 2, 3, 5? Yes. And these add up to 16. Oh, this is a 1, 4, 6 triple. I hadn't seen that happening. So 4 comes out of those cells, and that's a 4. That's a 3. This is a 5, 7, 8 triple, and 8's not allowed in row 3, column 4. I don't know. I thought that would resolve something here. This 2, 3 pair's not done. There's still more, and I do remember with Scott's previous, certainly with the first puzzle we did by him on the channel, there was a lovely break-in, and I got going, and then I got completely stuck after that. It was to do with placing all the 4s in the grid at the start. No, they were all placed for us, and then there was something that flowed from that, and then I got so badly stuck. Let's hope that doesn't happen again today. We will see. Sudoku somehow. How's it going to work? This is quite limited by the digits it can see in its row and column. Maybe there's actually some joy to be had. I was going to look at this cell, but it can be 2, 3, 4, 5, 6, or 7. And this can obviously be a 1. Now, this cannot be a 1. There's a lovely deduction. Right, these yellow cells add up to 16. If this was a 1, this pair would add up to 15. They would either be 9, 6 or 8, 7. They would include either a 9 or an 8. Neither of these cells can have a 9 or 8 in them. This one, which we marked, has 9 in the column and 8 in the row. This one, conversely, has 9 in the row and 8 in the column. And that means, and since neither can be 9, 8, the most they can add up to together is 13. And this cannot be 1 or even 2. That is not the 1. The 1 in the box is somewhat disappointingly on the 10 diagonal, but it gives us the 1 in box 2. What have I just done there? I was trying to get 1 out of this cell. There we go. Now, it's disappointing because there's quite a lot of combinations of 9 in those two cells. Actually, I'm going to pencil mark them. 2, 3, 4, 5, not 4. 2, 3, 5, 6, 8 by Sudoku. I'm going to get rid of 8. This can now be 7, 6, 4, or 3. Oh, I can't rule any of them out. Well, that was rubbish pencil marking. Oh, bother. I've still got these cells. I haven't even coloured them. What they were going to, I knew what they were going to add to a while ago. 10, 15, 20. They're going to add to 9. If that's a 2, these add to 7. If If that's a 3, these add to 6 and are definitely a 2-4 pair at that point. Oh, no, we're going to have to find something clever, I think. And I don't know if I've got anything in my locker. Hang on. Where's 9 in row 3? That's not that clever. Simple enough question. And there's only one. The one potential answer doesn't involve accidentally clicking on the pen tool button and then writing a 9, writing a O into the cell. So we got 9. Now, that couldn't be 2, I worked out earlier. That's not really interesting. 8, though. 8 is in one of those two, because we've got 8 there. Oh, hang on. No, 8 might be in the corner. Those two would add up to 8. They certainly can do. Interestingly, 7 can't be in the corner, because both of those would add up to 9, and both of those would add up to 9, but they have an overlapping cell, so both of those would be the same. So this can't be 2 or 7, or 1 or 9, or 5 or 6. I'm going to write 3, 4, 8 in the cell. But this is not the clever thing. There's a clever thing to do. I feel there's a clever thing to do. I might be wrong. There might be just something that you're shouting at because it's blindingly obvious now. 8 in this box is in one of those cells. This triple of 2, 3, 4, it's odd that that hasn't unwound at all. Okay, if this was 3 or 4, that digit must be here in row 6. Oh, that's nice. Right, this can't be 3, because that would be 3 in row 6. And in box 9, that would be 3. And then where could you put 3 in box 7? That's very clever. That's a sort of Y-wing hinged on row 5, column 9, which cannot be 3. Now, annoyingly, that same idea doesn't work for 4s because it's not... We already know where 4 is in box 7. It's a totally different kettle of fish. However, this digit in column 8 has to be there, so that's not allowed to be a 3 anymore. Now, that's got a little bit constraining, maybe, on the light blue cells, which add up to 9. If this is a 4, these two add up to 5 and are a 2, 3 pair. If that's a 2, they add up to 7, and that can be 5 and 4. I can't delete any digit out of this cell. Oh, hang on. Where does 4 go in row 3? Look, there's a 4 looking at that cell. There's only one cell where 4 can go. So that's a 6. This is now not a 6. That's not a 3. Well, I mean, that's not uninteresting, I feel. 9, 5, 1, 8. This is 2, 3, 4, 6, or 7. Oh, I've got 9 looking at a 3, 9 pair, just staring right at it. That's, I think, the last 9 in the grid. Now, I don't have 3 in the blues here. And I think that's significant. So I've got to get the blues to add up to 9. If that is a 3, that's a 2, 4 pair. If that's a 2, these add up to 7, and they must be 5, 2. I felt like that was something, and it didn't quite turn into anything. Now these two, they were going to add up to 11 or 12. Right, here's the next question. Where is 3 in this box? It's not in those two, because they can't be 3, 8 or 3, 9. Let me just check my maths here, because I don't want to get a memory mistake. 15, 25, 26. This is 2 or 3. 28 or 29, yes. Reds up here do add up to 11 or 12, and they can't contain a 3. Now we know 3 is in one of those two, so they are a 3-6 pair. Now we know 6 is not in the reds, and 7 is in the reds, along with, since they add up to 11 or 12, either 4 or 5. That one can't be a 4 by Sudoku, and this one can't be a 5. Oh, come on. They're nearly done. That's a 5-7 pair in row 3, so that's not a 5. Oh, goodness gracious. I thought we were literally there, and now I don't feel we are. I'm sure something has broken open. I just can't find what it is. 918. I'm looking at every row, column, box I can see. Maybe not enough of the diagonals. These add to 16. These two add to 9. Oh, hang on. If that's an 8, these two add up to 8. There's no way for them to do that. How did I know this wasn't a 5? Because this couldn't be a 4. Yes. There's no way for these to add up to 8, so we don't have 8 in the corner. Now the way to look at that is these add up to 16, but we're selecting from 3, 4, 6, 7, which are 4 numbers that add up to 20. So the one number in there that is not part of the group that adds to 16 is 20 minus 16 equals 4. So I remove 4, and we know that it's a 376, and that gives us 3 in the corner, losing its religion and proving its position. And that is probably going to disambiguate the whole puzzle. So 6 and 3 up there. That gives us 6 and 7. That gives us 2 and 3. That gives us 3 and 2 down here. That 3 makes that a 4. This is 3. This 2-4 pair is done. Everything in box 3 must be done now. 7, 4, 5, 2. And the reds do add up to 16, and the blues do add up to 9. The yellows add up to 16. That's exactly what we wanted. This becomes a 7. Oh, this 10 sum is the one thing we haven't done with a clue. That's a 2. That's a 5 now. 2, 7 to finish the row. 6, 3, 8 here. I know 6 goes in the middle, and I know that's therefore 8. And we definitely are finishing off. Every column can be done now. And every row, and every box, and every line, and every little killer clue. And there we go. Lovely. That is a really good puzzle, Scott. Excellent stuff. At 35 minutes. Just look, if you round up my time of 34:31, it is 35 minutes. I still don't know why the puzzle is called 35. Was one of the key sums? Did I don't remember saying the number 35 at any point, but I may be missing the point on that. And maybe there are other reasons for the puzzle to be called 35. I suppose it begins with 35 in the top left corner. It was very clever anyway, and really an exhibition of how a puzzle gradually unfolds piece by piece as you work it out. It's lovely stuff. I wonder if I overcomplicated some of the steps in the second half. Don't know, may not have done, but I really enjoyed solving it. So I hope you have fun with that one, and I will see you again tomorrow. Thank you for watching us on the channel as always, and bye for now.